All right, all right. So today we are going to try and do the same thing we did yesterday, except we don't have a graph, okay? So there's got to be a way for us to be able to figure out where a function is positive or negative or, whatever it is we want to do, where it is, I don't have a graph of it, okay? So yeah, I mean, I guess you could take the time to graph them and do it out that way. But they're not always going to be quadratics. Today they are. I left them a little bit on the easier side just for today to get our feet wet with them. But we're eventually going to be having rational expressions. So you have a polynomial divided by a polynomial. You would not want to graph that, would take way too long. So anyway, we're going to go over how to solve these algebraically, and it's not as bad as you think. So let's get right to it. So I'm gonna, oh geez Louise, hold on. Okay, there we go. So we're gonna look at number one. Okay, so our steps for this are actually not too bad. The first thing that you always want to do is you want to factor this thing. Okay, we're going to factor it, and we're going to find what we refer to as critical points. Where is something happening on this graph? Okay, so let's start there. And if I'm just going to, I always want to make sure that the whole thing is set. I know it's not equal, but equal to 0. I know we have an inequality, but so for example, if I had like a 2x over here, I'd want to move the 2x over to the left-hand side. All of these already have a 0 on one side, so that's good. Tomorrow, that may not be the case. But anyway, I'm looking here. I don't like that a is in a positive 1, so I'm going to start by factoring out a negative 1. And then I can factor that trinomial in there. So factors of 10 that add to be a negative 7 are going to be a negative 5 and a negative 2. Okay, so I have this thing factored, and wherever, if I were to set my factors equal to 0 and solve, I would get a positive 5 and a positive 2. So that, the positive 5 and the positive 2 are my two critical values, okay? So what we like to do is you're going to take a number line, and you're going to plot any critical values you have right on that number line. So I had a positive 2, and I also had a positive 5. Okay, and what we need to do is we need to ask ourselves, first of all, I always ask myself if those critical points would work. If I actually took 2 and I plugged it in back up into the original, if I plug 2 in, am I going to get a value that is less than 0? You already know this answer. And the answer is no, because if I plug in 2, I get 0. Exactly 0, right? If I plug in a 2 right here, that turns this whole factor into a 0, the whole thing gets wiped out. So if I plug in 2, it is not less than 0, it's equal to 0. So that means that 2, I'm going to put an open circle above it because it is not part of my solution set. Doesn't work, okay? The same thing is going to happen with 5. If I plug in positive 5, it equals 0, and I want less than 0. So open circle there, okay? If this had had the bar underneath, then I would have used closed circles for those, but they don't, they're open, okay? So now what I need to do is I basically need to use test points that are on the intervals in between 2 and 5. So I want to pick a number over here to plug in between 2 and 5 to plug in, and something greater than 5 to plug in. And I'm going to test, so that'll be 3 numbers in this case. I'm going to test the 3. And if it works, then it's part of my solution set. And if it doesn't, then it's not. Okay, so let's try this. So I'm going to pick a number less than 2. So I might as well pick 0, right? And I'm also going to recommend that when you plug in a number, that you go back to the original and you plug it in. Okay, so if I plug in 0 into the original, I get, I don't really have any room up there, but I'm going to get 0 plus 0 minus 10 is less than 0. Is that true? Is negative 10 less than 0? Yes, it is. So I'm going to write a little yes, which means that I'm going to include all of that in my solution set, because that works. Now I'm going to pick a number between 2 and 5. It doesn't matter what number you pick. I don't know, I'm gonna pick 3. So if I plug 3 up into the original, be careful now, when you do negative, when this right here, that notation means to take 3, square it, and then take its opposite. So that's actually -9 plus 21 minus 10. Is that less than 0? Well, let's see. No, it's not, because that would be +2, and that is not less than 0, so no. That is not part of my solution set in there. You only have to pick one number, any number in the range in between 2 and 5. So you don't have to now try 4, right? Any number in between. So now I'm just going to pick any number greater than 5. I don't know, I like to pick 10 because it's easy. So it would be a -100 plus 70 minus 10. Is that in fact less than 0? I ran out of room there. Yes, it is. So I'm going to include this portion. Okay, so now that I kind of have this all laid out, I'm ready to say what my answer is using interval notation. So I'll stick it right here. I'm coming, everything from -infinity worked all the way up until 2. I cannot include 2 though, because 2 itself didn't work. And then I need to join that with everything greater than 5. So from 5 off to +infinity. Okay, so hopefully that wasn't too bad. Let's go ahead and try number 2. See how that one works. Okay. All right, so again, first I want to factor, so I'm going to take out that -1, x squared plus 10x plus 16. Let's factor what's in there. That would be an x plus 2, x plus 8. So my critical points here are going to be a -2 and a -8. So I'll have -8 here, I'll have -2 here. And I want to, again, ask myself if -8 and -2 themselves are going to work. And in this case, the answer is no, because I'm looking for greater than 0, and those will give me zeros. So I will not be including -8 and -2. Okay, now let's just test some numbers. So why don't I try -10? So if I plug it in, right, and that's how I'm doing it. -10 squared is 100, but then you take the opposite, so that would be a -100. And then -10 times a -10 is now a +100, so those two just cancel out. And then a -16, is that greater than 0? No, it is not. So this region is not part of my solution, okay? Now I'll pick in between -8 and -2, so how about -3? So that would get me a -9 plus 30 minus 16. And is that positive? Yes, it is. So yes, in between -8 and -2 works. And then I'm going to pick any number greater than -2. So I would just plug in 0 because it's the easiest, and I get -16, which is not greater than 0. So that's a no. Okay, now you also might be noticing that it's going yes, no, yes, no, yes, no. As you do these out, yes, most of the time that is true, but when we start getting to more complicated ones that are fractions, that is not always the case. So you can't just rely on an alternating pattern, okay? So anyway, let's go ahead and write our answer in interval notation. I am not going to include -8, but I am going to include everything from -8 to -2. Okay, so that one would look just like that. All right, let's try 3. Uh-oh, I hear my son. Hold on, I'll pause it. Hey, Mommy. Hey, honey. He made a picture for you. Okay, so we were about to try number 3. So let's take a look. We're going to start off by factoring like usual. So take out that -1, x squared plus 8x plus 16. Let's go ahead and factor that again. We're going to get x plus 4 and another x plus 4. Okay, so that means our only critical value for this is -4. Okay, and then we just ask ourselves, okay, at -4, I want to be less than 0, and it won't be, it'll be equal. So I'm going to put an open dot on -4, and then I'm going to plug in a number less than -4. So let's go -5. So that's going to be a -25 plus 40 minus 16. Is that less than or equal to 0? No, right? 31, nope, because I get a negative. Oh wait, yes it is. So I get -1, and that I want it to be less than 0, so it is. Okay, and then I try a number bigger than -4. So I'll just pick 0. If I plug in 0, I get -16, which is less than 0. So yes, that works too. So that means I'm going to include everything except -4. Everything here, and then everything here is going to work out just fine. All right, so if we're going to write that in interval notation, I'm going to come from -infinity all the way up until -4, but I cannot include -4, so I'm going to have to jump over it like that. Okay, cool. Let's do one more together, and then I will leave the rest for you to try. So let's slide on over to number 4. Okay. All right, so take out -1, 3x squared plus 4x minus 15. And now I want greater than or equal to 0. Okay, so I'm going to have to factor in the middle there. So you factor however you do it. I do the A times C, a kind of weird method. But you do whatever you like. Doesn't really matter as long as we all end up in the same spot. So that's going to be an x plus 9, x minus 5. But then I have to divide by 3 because I multiplied by 3 before. So my factors are going to be x plus 3 and 3x minus 5. So however you did it, just make sure that you end up where I am. And that means I'm going to have some critical values at -3, and then another one at +5/3. Okay, so let's test some. I can have it equal to 0. So when I plug in -3 or 5/3, those values do work, right? Because it gets me a 0 and I'm allowed to have 0. So I'm going to do closed. It's kind of hard to show closed dots on these, but those are closed dots because yes, I want to include those as part of my answer. So let's just throw in -4. So that would be, let's see. I'd get a -40, I'll do it up here, -48, and then +16 plus 15. And that's going to get me a negative, and I want greater than or equal to 0. So that does not work over here. And then I'm going to pick a number in between -3 and 5/3. So I might as well pick 0. So I would get out 15, which is greater than or equal to 0. So that's a yes. That's going to work, this whole region here. And then something bigger than 5/3. So, oh, I don't know. I'll pick 2. So if I plug in 2, that's going to get me -12 minus 8 plus 15. And that is going to be negative. So that's a no there. Okay, so the region that does work is everything from -3 to 5/3, and I'm going to include both of those endpoints because I can have or equal to 0. So I'm going to write that, I'll stick it in right here, closed brackets. I can go from -3 to a +5/3. And there's my answer to that one. Okay, so hopefully this helps you get the hang of it. If you do have questions, please let me know, because it's only going to get more complicated from here. So we'll take it piece by piece, but please reach out if you are confused.